decimal madness. We don't want that. Alright, I know what I'm going to do. So let me just create the, you know what? Why not? Why not use these numbers and try and convert them to base 2. So you just imagine that these are both base 10 numbers anyway. I will go convert them to base 2. Might as well. So now there's a lot of numbers that we can start from the most ridiculous. Yeah, we can. Let me see. Dear God. 4096 plus 4000. Yeah, man. See there? Alright, so watch this now. We have the number 8192. Yeah? Now let me divide it by 2 just to be sure that one may do make sense. So 4, 6, 8, 10, 12, 14, 16, 18. Alright, so 1, 2, 3, 4. Now this is one smaller everything, so that's a 0, right? And then now we have 19. 19 is bigger than 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 19 minus 18 leave you with 1. 12 is exactly 1, 2, 3, 4, 5, 6. Yeah. Okay. Yeah. So that take care of that. Cool. So therefore, what comes after that is definitely that. So yeah. So 4096. You divide that by 2. This is 2048. After that it's 1024. Then 512. 256. 128. 64. 32. 16. 8. Yeah. I think we know what go down after that, right? I don't know if I can put it over here too. Right? 4, 2, 1. Right? So therefore, start with 0, 1, 2, 3, 4, 5, 'So let me do this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Now, as ridiculous as this is, if we're comparing this to this, 8192 is bigger. It's bigger than 8160, right? Bigger than this. So we can't use that. And it's only zeros and ones we have. So therefore, the largest amount of 4096 would have to be 1. Right? It have to be 1. Right? We're not going to get no, because all we have in binary is 0 and 1. Right? So we're we're going to subtract the 4096 from this. Alright. So let me see now. Add 4 to that. I get what? I get my 100 from that. Oh, hold on. Let me be careful. Allow me to be careful. Let's say that that is 4,100 from that. If I take 4,100 from that, right, I'm left with 4,060. So therefore I have, if I add them together, I have 4,064. Now, you can add them and see if that actually work. 4,064 plus 4,096. Yeah, and it worked. So, we have at least one of these. So I could just do this. Now, do we need 2048? Well, it's the largest thing after that. So yeah, we can use it. Alright, we can use the 2048. So the difference with this now is that you don't have to worry. The only possibilities you can get with base 2 is 0 and 1. Alright, just 0 and your 1. Alright. If I add 16 to that, I get 64. Yeah. So therefore this is, yeah, 8 plus 6, 14, carry 1. Yeah. That's that. So therefore I have at least one of this and one of this. So I have at least one. It will start to make sense after a little while. So now, can we use 1024? We can, since it's smaller. So, when we subtract that from that now, what we have now? 1016 from that, and 1016 from that is, so this is looking a lot like 992. Yeah, 992. So that means we use one of this, one of this, one of this. Ah. Okay. Now I go add it again just to be sure. 992, and I go add that to 1024. Yeah. Just making sure we have everything in order. So 1024, 2 to the 10, 2048, 2 to the 11, 4096. Right, cool. We have that. Well, we might as well use the 512. We might as well, because it's the largest thing that come after it, so might as well use it. So we have 512 from that. This leaves us with 480. Alright? So, one of each of these. Then we have to use 256. Anyway, alright, so I could write the 1 times 256. Now, if I add 4 to this, alright, 0 carry on 1, 8 minus 6, that give me 2. So, yeah, 224. Might as well use the 128. $128. 100 minus 4 look like 96. Okay, well, we just have 2 more things. We just have 2 more for do and we're done. And this is how I know. If I take 64 from this, I'm left with 32. And I take 32 from this, I'm left with nothing. If I add 64 plus that, I end up with 96. So I know that I'm going to have 64 and 32. So if I add 64 and 32 and I get 96, I might as well say 1 and 1 and then 0 for everything else. Right? Yeah. Yeah, that was a big number. That was a big number. So this is 1 1 1 1 1 1 1 1. How many of them? What? Oh, that's a lot. Yeah, that was more than I thought it was. So 1 2 3 4 5 6 7 8. Yes, yes. So 8 ones, 5 zeros, and 8 plus 5 is 13. So yeah, that kind of makes sense. Kind of makes sense. So yeah, if we can, boy, this. So 1 1 1 1 1 1 1 1 1 2 3 4 5. This entire thing up here in base 2 is what that is. Base 2, if we're converting base 2 to base 10, I believe that that's a lot easier to do. Whole heap easier. Now this was a bit tedious because of the number that we had. The number was kind of big. You know. Number was big. So first we use 8,160. Now let's see what happens if we use something like, so we're done with this one, right? We're done with that one. So let's try 5,967 and see what ends up being our case right here. So I could get rid of that. Let's get rid of that. We could still keep this. And let's get rid of that. Get rid of that, and let's put down here 5,967. Oh, I don't need these zeros here either. Yeah. Okay. All right. So obviously we can rule out this. We can rule out the 8,192. We can rule out that. Now we can use at least one of the 4,096. So let's use one of that. So we have 4 096. Alright, let me make my life easy. If I add 4 to that number, I get 4,100. Alright, 5 minus 4 is 1. 9 minus 1 is 8. 6 minus 0 is... I don't know. What am I doing a while ago? Right? So 4, yeah. 4,001 from that, yeah. And if I add this to that, I'd get 1871. So let me write that now. 1871. Alright, good. Now here's the problem. 2048 is bigger than this. So now we will have to put a 0 right here. So we can't use no parts of 2048. Now we have to move to 1024. Let's use one of 1024, right? So we have 1024. What do I add to this to make my life easier? So if I add 6 to that, carry 1, 3 plus 7. So I have that. If I take 1100 from that, I'd end up with what? 18 minus 11. Yeah. So now that's going to be, well, if I add the two of them, this is going to be 847. Alright, so 1 carry the 1. Yeah. Alright, no, 512 can definitely fit, so we might as well use it. So let's put 512 into this. So this will be 7 minus 2, 5. This is 3. This is 3. Then you can fit 256. We don't forget that. Right? So might as well subtract the 256 from this. So 256. Alright, 44. If I add 44 to that, I get 300. So 44 plus 35. So add 44 to 35. What that? That's looking like 79. So that's looking like 79. Make sure I write that little better than that. Now 256 plus 79 is in fact, yeah, 335. Right, so we just want to make sure that go on. Now 128 is bigger than this, so we can't use it. Right? Yeah. So we couldn't use any of 2048. We couldn't use 128. Now we can use 64. So let's subtract 64 from all of this. So we have 64. So I'm going to put a 1 beside it. 9 minus 4, we have 5. 7 minus 6. A lie. So 79. Yeah. So now we're not a good spot now. 15 is smaller than 32. We can't use any amount of 32. And it's also smaller than 16, so we can't use that neither. So what's your joke now? We don't have a choice but to use 8, 4, 2, and 1. Because what? 4 plus 2 is 6 plus 1, 7. 7 plus 8 give us 15. So we have to use 1 of each. So 1 here, 1 here, 1 here, and a 1 right there. Yeah. Yeah, it's a shame. Obviously, you know what? It's okay. I can make the adjustment so that it makes a little bit more sense. So let me try and move this up here a little bit, and then yeah, why not? So we knew what we were doing, right? Now we're converting at the base 2. Alright. So we have 8,192 here, 4,096, 2048, 1,024, and then we just let's write it over so that we have everything we need. Alright, hold on, you know. So after this we have 512, 256, 128, 64, 32, 16, 8, 4, 2, and then 1. Right. So this was to the power of 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, and of course right. Now what we said we could not use was the 8,192. Right, we used one of 4,096. We used 2048. We used one of 1,024, one of 512, 256. We didn't use any of, we never used 128, but we used 64, and we never used 32 or 16. But then we used 8, 4, 2, and 1. 8 plus 4, 12 plus 2, 14 plus 1, right? So we used 1 of all of that. So if we write it in this order now, coming down, yeah, and that should take care of that. So okay, now that we've done that, if we were to write it, it would be 10111 01001. Yeah. So this would be the base 2 of the number of this number in base 10. Yeah. And if you can do the difficult ones, you can do the easy ones. All right, let us say I wanted to say convert 87, that's in base 10, and I want to convert that to base 2. Well, let's see the first number that 87 bigger than, or rather, let's take out the first number that's bigger than 87 actually. It would be 128. That's the number that would be bigger than 87. So we'd have to start with 64 going down. We can't go above 64. So that means if we subtract 64 from this, we have a better idea of where we stand. So we have at least a 64. When we're done, we're at 23. Now, that means that 23 smaller than, it's smaller than the 32, so we're now going to be able to use that. So we now have to skip to 16. Right? We'll have to skip to 16. Now this is 7. Now what I know about 7 is that if you add 4 plus 2 plus 1, you get 7. Right? So therefore, we would, okay. So just so that we understand what just happened, we'll be using a 1. We don't use a 32. We use a 16. We don't use any 8, but we use one of these. Or rather, yeah, each one of these. So therefore, 87 would be, just so that, let me just write it so that. So we would have 1 0 1 0 1 1 1. That would be our, this would be our base 2 equivalent of the number 87. So let's see, 0 1 2 3 4 5 6. 2 to the 6, 64. We don't use any of the 5, but we use what? 2 to the 4. Yeah. So we use 2 to the 6, 2 to the 4, and then we use 2, 1, and 0. So we don't use 2 to the 5, and we don't use 2 to the 3. Yeah. So if you can mash up the bigger number them when you get back to the smaller ones, it just, everything work itself out. Alright. Give me 1 second, hold on. Give me 1 second here.